Folks, my next section is about network automation with Neutron. My name is Sirish Raghuram. I'm the co-founder and CEO at Platform 9. And like we did with a few other sections today, I'd like to explain what it is that we do with OpenStack Neutron. So Neutron, we reviewed OpenStack architecture. Neutron is the networking component that integrates with your networking infrastructure. These networks could be a variety of underlying networks. It could be traditional vSwitches, it could be VLAN-based networks, it could be VXLAN, GRE. You could really go to town with this. Why does this matter? I'd like to explain this. There's a lot of noise about SDN, but I'd like to explain why this matters, right? So if you have a physical network, there's a wire somewhere that's going to a physical switch, and you have hypervisors that are on this physical network. What you're trying to do with the cloud platform is you're trying to make it easy for the existing infrastructure to be usable by the people who want to use it and get things done, right? So with compute, you'd like to make it possible to use some slice of compute that you have. With storage, you'd like it to be possible to use some slice of storage that you have. With networking, you'd like it to be possible for them to use some slice of networking that you have, and that may not just be the networks that already exist, but you may want to allow them to do things like deploy an isolated network, a fenced network, and run certain penetrative test experiments, or manage the I/O segmentation that happens across different networks, right? So what Neutron helps us is with those things precisely. So if you take end users, if you take IT is concerned about what are the networks that I have, what is the topology that exists, where are the storage networks, VLANs where the storage I/O happening, database servers running, infrastructure services running. What are the ones that I want to give access to my tenants to? And the end users are concerned about provisioning workloads and hooking them up to networks and deploying fenced networks and getting IP addresses and hooking up VMs to security groups. This is what the OpenStack layer makes possible, and in networking, it does that. In the demos that I've been showing you so far, we're using the networks that already were discovered. But if to do more advanced things like deploy a segment of a network, a virtual segment, you need to use Neutron, and that works with a local network node. This is analogous to the on-premises glance node that we spoke about earlier today. So the network node is orchestrating on behalf of the OpenStack controller and is orchestrating operations on the hypervisor on your behalf. Okay? So I'd like to actually show you this with a very quick demo, the setup portion. So this is an environment that I have that has three hypervisors, three servers rather, that haven't been initialized yet. So we did a vSphere demo earlier today. I'm actually now going to onboard a Linux-based environment, completely bring it on with Neutron networking, and actually get to a point where we can provision this. Hopefully my network holds up. And
normally there'd be like a KVM hypervisor in this environment, but you're just bringing on a Linux bare server environment here under
so with our servers,
OpenStack control plane?
So with our model, because the management happens from the cloud, the prerequisite is actually not even to have KVM, it's to have Linux. And if you don't have KVM, we will deploy and manage that, we'll deploy that for you, right?
Okay.
But,
so you actually...
but you could have KVM and you could have existing VMs, like you could have an existing VMware environment and you could have VMs running on it. So that's supported too. So what I'm going to be deploying is essentially this topology where there's two hypervisors and there's a third node which is going to act as a network node and help us orchestrate network management across these servers. So we have these three servers. I'm going to go through this relatively quickly because while we speak. So I'm going to make this server the network node. We have a prerequisites document that talks about this. I have a bridge device there that's actually connected to my external network, which is a Comcast network. And I'm going to map that as the external network.
Now, do you guys...
help if I can type? Yeah. Go ahead.
Because it's using Neutron, are you guys supporting Open vSwitch now on this, or is it still just standard bridges?
It is based on Open vSwitch.
Okay.
Yeah. So I'm creating the BREX external network, mapping that to a physical network configuration, which would be replicated on other servers that are mapped to use this particular network. I'm going to map this to being based on a VLAN. I'm not going to authorize this to be a hypervisor. I'm not going to authorize this to be an image library. I'm not going to authorize this to be a block storage. I want this to be a dedicated network node. with that done, I'm going to authorize 2 more servers. I'm going to make this a hypervisor. This is my image library, so I'm also going to ask it to run my exposed VM console here. I'm going to choose the physical network configuration that I just deployed earlier, and I'm going to go ahead and say make this server the image library with the glance images being available from this API endpoint locally. This is not going to do Cinder. We just did a Cinder demo a little while back. Okay, maybe because my network node is not authorized yet. Okay, so I'm going to make this a hypervisor. This third node is going to be a hypervisor. So going back to the diagram that I showed you earlier, we're authorizing 3 servers, 1 network node, 2 hypervisors, and one of those is actually going to be an image library, and not a block storage role. Let this authorize. So these servers are going to take a couple of minutes to come up. While that's coming up, I want to go ahead and create an external network. So this is actually going to map to my Comcast physical external network that I have in my environment. So I'm going to call this Comcast. I'm going to say assign this to the service tenant. So in all of the demos that I've been doing, I've been using a single tenant for convenience in the interest of time. You could be defining multiple tenants and having this network available to a specific tenant. For today, we're just going to do everything in the context of a single tenant. And this Comcast network is not mapped to a VLAN in my data center. It's a flat network. So I'm actually just going to say this is flat. I have some subnet info that I need to provide.
And it's creating all my
Could you say that again?
it's creating all my OVS, all my configurations on the back end. I don't have to predefine that.
It does all of that for you.
Okay.
So this is the config info that I need. So I'm going to give this a CIDR, and I'm actually going to give it an allocation pool from here. So this is where this is the range of IP addresses that this network is going to be mapped to. So that should do the portion of creating the network. Now, one thing in the interest of, I do have a new image library, so I'm going to go ahead and stage a test image. So in the image library that I have, once it comes up, you should see a test image here. So I've just staged a test image for us. Okay, so one of the first use cases, we'll let that stew. It takes 2 or 3 minutes for that to complete. One of the first use cases, I want to talk about two use cases today, and there's a lot that you can talk about on networking, but I want to talk about 2 use cases.
Suresh, sorry, before we move on to that, just one question about all of this stuff we've done so far. You're using a GUI to actually go in there and type it and do it all manually. I'm assuming there's API stuff behind.
All of these are based on
all of this is API driven, so I can actually script all of this and program it through something else.
Absolutely.
Fully automated. Okay.
Absolutely. So the UI is a strict API client, right? Yep. So it's a REST API.
Cool. Okay.
Good question. Thank you. So one of the first use cases is using an existing network. So you may have a iSCSI network. You may have a database instances running on certain VLANs. You may have storage traffic dedicated on certain VLANs. And you may have an end user who comes in and says, hey, I need to deploy XYZ that needs to be hooked up to that database. So not only do you need to provision that database account for that user, but you may need to actually make sure that their web application has a way to communicate to the database, which means that there needs to be network connectivity between the workload that they'll be deploying and the database instance, the network that the database instance is available on. So that's an example. DMZs are another example where you want to take an existing network topology and bring that into the system so that you are now aware of this. You can model it as being, this is the database network, this is a storage network, and so on and so forth. And you can hook up the right VMs to the right networks. So in the OpenStack world, you do that by, Neutron world, you do that by deploying what is called a provider network. And we'll be doing that in a minute. I just want to make sure that we authorized a network node, we authorized a compute node, and a hypervisor. I want to make sure that they all came back up. Any questions while we wait for this? It looks like my system is fairly slow. So
I'm not a networking person, so whatever I say, take with a big grain of salt. But OpenFlow, software-defined networking, is that what you did with this Neutron networking node?
Yes, so what we did is we defined one node which is on my infrastructure, in my LAN, which is going to act as the network orchestrator, a centralized agent that will help act as a router and so on and so forth. And we authorized 3 other servers and map that to the physical network configuration that we had defined when we authorized the network node in the first place. So when we defined the network node, we defined a physical network configuration, and we gave it a certain bridge name, and those bridges would now be provisioned on those hypervisors using OVS.
So in this case, you actually deployed Neutron capabilities to this node. Is that what you?
That's right.
Okay, I got you. So not like you're firing up NSX or anything like that, or.
So NSX could be viewed as an alternative for this Neutron node. So you'd say NSX, instead of deploying something like this, you have an NSX deployment, as we were talking about earlier, and you'd want to have OpenStack integrate with that NSX deployment. So that would be an alternative. So we have, I think, an environment here where I can go ahead now and create a tenant network, so a provider network. So this provider network, let's take a MySQL database network. I'm going to create a MySQL network, and I can choose which is the tenant that needs access to the MySQL network and choose to give them access to that. And I'm going to map this to the VLAN where my MySQL instance is actually running, and that is VLAN 634, say, for example. And the physical network that this actually maps to is physical network. So let's go ahead, and I'm going to provide it with a CIDR that I can use. Would help to put that in the right place. I'm going to call this a MySQL subnet. And I'm not going to allocate the gateway. I'm not going to allocate anything else other than that. So this is how you take an existing network topology that you have. It could be database servers, DMZs, storage I/O related network where you have certain arrays available, all of those, and you bring that into your system. And this network, now you can deploy instances, and if it needed to communicate with MySQL, you'd need to make sure that it had a connection to this particular network, right? So when you go into the instance creation wizard, you'd want to make sure that you pick the MySQL network if it needed to talk to MySQL.
And who is actually doing this workflow? Is it the tenant admin?
It's a great question.
Right.
So the provider network, where you're mapping it to a physical network infrastructure, is being done by the admin.
Exactly.
Because this is where you're saying, I have physical domain things that you need to know about. Like MySQL, I've hooked it up a certain way. You need to know about that. This is my way of bringing it in and then giving you, the tenant user, access to that network, saying if you need to deploy a SQL, something that needs to talk to SQL, make sure that it's connected to that network.
Yeah. Yeah.
Right?
But that's not entirely multi-tenant, right? So if I want to use PF9,
We'll now talk to that. So this is a case where you import an existing use case, existing topology.
Yeah.
The canonical use case for networking is, something like this, right? You have an N-tier application, you have routers, load balancers, web applications, which all of these are fenced off, so they can only talk to the people that they're supposed to be talking to, which is talking to an application tier, which is load balanced, and where internally it's being routed across multiple application instances. And those in turn are routed to a database, which is again load balanced, and the security groups that are kind of laying down strict isolation between each of these layers.
So if I'm using an external DHCP server, not an OpenStack-driven IP provider?
Yes, that's supported.
It is supported. It'll discover it. It'll show it, so I can.
So you have a choice. When we created the network, you have a choice of saying, run the DHCP server yourself versus I have a DHCP server that's working on that network.
So integration with like Infoblox or anything, or is that strictly just an OpenStack? Like if it's supported by OpenStack?
If it's supported by OpenStack, but the model is that you have choice in terms of who's doing the IP address allocation. Is it the network node that's essentially orchestrating that for you, or is it an external system? And you could choose to have it be an external system.
And it picks up those from an external system. It'll show in.
Correct,
because
we will discover it. So what will happen is that we'll provision an instance, it'll come on that network, your external system will give it an IP address, and because of our discovery capability, like exactly what we discussed with vSphere, we will discover that IP address in the next refresh.
Okay.
Right? So this is a canonical example. I'm going to try and do a quick demo that essentially creates a logical network. I'm now doing this in the persona of a tenant user. Even though I'm logged in as the admin, I'm now acting as the tenant user who is going to go do DevOpsy things. Okay, so I'm going to create a tenant network. Let me call this a test dev network. I'm going to keep this in the same tenant context. Let me go pick up my subnet information from here. I'm going to call this a test dev subnet. and I'm going to give it this CIDR. I don't care about DNS. I could give it DNS if I needed to. Done. Okay. Now I could go ahead and provision an instance onto this network. I'm going to use the basic Cirrus disk image that I had, give it a basic flavor, and I'm going to put this on a test dev instance because I'm going to call this test dev worker 35. Okay. Note that I'm getting asked about security groups, and I'm going to say allow all traffic. Okay. Or I could do something more restrictive, like allow all outbound and SSH inbound, or you could choose what these are. Now you can make your own security groups. I'm going to go through this relatively quickly. That instance is going to come up. It's going to take 2 or 3 minutes, and it's going to come up. This network, I gave it an isolated subnet. Okay, it's going to come up with an IP address on that subnet, but you cannot reach it because we didn't do anything to bind that subnet to the external world, right? And in the Amazon Web Services world, you do this using floating IPs, and you'd actually go and provision one, and you'd attach that to the VM instance. So that is exactly what we're going to do here. So what I'm going to go here into the networks view is before I can allocate a floating IP, I'm actually going to create a router. So I can say test dev router, and I'm going to say external network to Comcast.
And again, this is the admin setting this up, right?
This router step is being done by the admin.
Yeah.
Correct. So now I can go into the router and I can say I want to add an interface. So I want to add an interface to my test dev network. Okay, and I'm going to add this interface. So what's going to happen is that this router is now going to be available to route between the external network and this isolated network that we have over there. Now that we've done that, we could go provision a floating IP. So I'm going to create a new floating IP address. I'm going to choose this to be coming from that external IP network. And then we don't have an instance yet, so I'm just going to create a new floating IP address. I don't think my instance is ready yet, but the idea is that once this instance comes up, I could now attach this floating IP to this instance and now actually be able to route to it, log into it, do things with it, right? Otherwise, it was in an isolated fence of its own. So the key constructs that I'm demonstrating, folks, is the ability to create a network segment. You do that with a tenant network. The ability to create a router and manage what the router is routing between. And the ability to provision a floating IP address, which is an IP address which is independent, and being able to map those to instances, and the ability to map instances to specific networks and specific floating IP addresses. These are the building blocks, and you could use this in any combination of ways. This is going to take a few more minutes, so I'm actually going to, well, now that this came up, maybe I'm tempted to linger on this a little more. Let's go into the floating IP. I'm going to assign the floating IP to this tenant, and once that is assigned, I should be able to go back to this, and you can see that this VM has this floating IP. So if I were to go in to my shell, and if I were to try and ping this, I don't think we have ping enabled there, but if I were to try and SSH into this, am I on the VPN? I am on the VPN. Where am I?
You're getting a connection refused, so that's good. Doesn't allow SSH, but it's open.
Because, let me see, what is this security group?
Didn't time out, did it?
Yeah, security group is.
The networking, let me go into edit security groups. I'm actually going to allow all traffic and say save and see if I get lucky.
Yep.
There you go. So you get the idea. I think I had something in the security group that prevented it. So my point being, if you were to look at networking and you were to look at the primitives that are needed, being able to create a virtual network segment, being able to deploy a router, hook that up to different networks, and being able to create floating IP addresses and associate that with VMs, you have all the building blocks here. We started from scratch. We started from 3 Linux servers, and we came up and running with an OpenStack-based private cloud with networking, SDN stuff. It's a pretty cool thing.
So how about other network services? So you showed us a router. What about like net or load balancing?
Load balancing is coming. It's not in the UI yet. Mm-hmm. It's actually, we're in beta with Neutron. It's actually in the API right now.
Yeah.
But it's coming, and we do more over time, right?
Yeah.
But the idea is to provide all the key constructs.
Exactly. Yeah.
And you'll be able to provide from external load balancing services as well. Like
That's right. So our philosophy is to, on networking, I think there's a need to provide a batteries included approach. So we provide this out of the box. But if you were to use your choice of SDN solution, then you're welcome to do so. And we'd partner with that because almost all SDN solutions are Neutron API compatible. So we can integrate with them, much like we do with Cinder.
So like ACI and all that.
Correct.